All right, so we're moving on to our first video for the year, and that video is going to be Unit 3A. So the number is representing what unit number we're in for the year, and then the A is telling us which part of that unit. So obviously A will be the first part, B will be the second part, and so on. And what we're going to be doing in this first part is solving one-step equations. So anyone who was in AIS last year would have done these extensively last year with Mr. Carlson, but since we have some new students and based on the pre-assessment we did overall, we did really well in solving these, but there's still a disconnect from too many people for us to move on in the order I was originally going to. So we're going to focus on this first to make sure that we're all on the same page and that we're all able to solve these one-step equations and how to show our work. And then we're going to start moving into some what might be new things for some of you and maybe not for a lot of you as well. But our learning objectives. So in every video, you're going to get your learning objectives. And that's pretty much at the end of this video. That is what you want to have at least a basic understanding of. That if someone were to ask you, what is an inverse operation, you would be able to give back some sort of answer. I'm not expecting that you have these mastered just because you watched a video. But now when you come into class the next day, you know what to expect. You know what we're working on. So we at least know the basics of that. All right, so that's our goal for these videos. It's not to master it. It's just that we have an understanding of what we're about to learn. And if someone were to ask you a basic question on it, you'd be able to give them some sort of answer. So we have just like a basic understanding. And then through coming in class and through the days, we will then turn that basic understanding into a mastery. All right, so at the end of this video, or at the end of all your videos, what you should be doing is going back to your learning objectives, and you should be checking them off that you do actually have some sort of understanding. And if you don't, what is it that you don't understand about that learning objective? And then make sure you're writing that question down so that I can help you the next day in class. All right, so at the end of this video, you're going to have to know what an inverse operation is. And then you'll also have to know how to solve just a one-step equation. So for all the first ones that we're doing for these first 2 days, they're all just going to be one-step equations. And then we're going to branch out and start doing things a little bit more challenging. But if you're already able to do some of these one-step equations, there will be work for you to work on and to challenge you as well. And then the last thing, this is one of the more important things as well, is you will know how to properly show your work when solving equations. So the problem is some of these one-step equations that you do, you can just look at the problem and kind of guess and check your way to the answer. But that's only for these types of problems. When we start moving into the harder ones that we're going to be doing in just a few short weeks, you're not going to be able to look at the problem and just guess your way through it. So you must show your work properly. Without showing your work properly, you will not get full credit. All right. So you must be able to show your work because as problems get harder and harder through math, when we if we understand what we're doing and able to show our work through step by step, just being able to understand what an inverse operation is and how to properly show that will allow for you to be able to go through any type of question and solve it correctly. All right, so now we're going to go ahead and start talking about inverse operations and our learning objectives and going through some examples. All right, so first off, inverse operations, what are they? So that's how you're always going to hear me talk about these and explain them. And they're defined as the operation that undoes what was done by the previous operation. So we're undoing something. So when we're seeing 5 times x or 5 times x is equal to some number, well, we're saying, okay, well, if x is being multiplied by 5, how do we undo multiplication? All right, so it's undoing the previous operations so that this way we can isolate our variable. So let's go ahead and show some examples of inverse operations so we can identify them a little bit more. So it's not just me talking about it, but showing you as well. All right, just to be able to show you inverse operations and what we mean by that is we're going to start it with just numbers and then we're going to translate this into variables in just a moment. But our goal for this is we're starting with the number 10 and then we want to end with the number 10. And I'm giving you 4 different operations. So you see every single one has a blue 10, meaning that's the number we're starting with and that's what we want to end with as well. And then I had the 4 different sections of adding, subtracting, multiplying, dividing. And in each of these cases, we're adding or subtracting or multiplying, dividing something to that number 10. So we're going to go through and solve it. Well, what is 10 plus 5? That is equal to 15. So our goal is to start with 10 and end with 10. So if I did 10 plus 5 is equal to 15 and I want to get back to that number 10, well, how do I do that? Well, 15 minus 5 will give me 10. So you see, I started with the number 10 and I ended with the number 10. And now in between, when I was adding 5, when I subtracted 5, it brought me back to my original number. So you see, it undid what we were just doing. We started with 10 and we added 5 and it gave me 15. Well, we wanted to undo the operation that was happening to it. And in this case, we added 5 to it. And to undo that operation, well, we then needed to subtract the same number, subtract 5. So the inverse operation, I'm going to write them all in red in parentheses, of addition or adding is subtracting. And we see that because we started with the number 10, we added 5 to it, and to get rid of or to undo the addition of 5 to that number 10 to get back to what we started with, we had to subtract that same number 5. So you see, we added 5, that was the operation we performed, and then to undo that operation, we had to subtract by 5. So by adding and subtracting by the same number, it will undo each other and bring us back to our original answer. So now, even before we do this next problem, you should have an idea then of what our inverse of subtracting might be. Well, 10 minus 8 is going to give me 2. If I want to get back to my original number of 10, well, then what do I need to do to that 2 to get back to 10? And in order to get back to 10, that means that I'm going to have to add, and I'm going to have to add 8. And 2 plus 8 will bring me back to my original number 10. So you see, I started with 10, I ended with 10. My original operation that I did to my 10 was subtracting by 8. And then to undo that subtraction to get back to my original number, I needed to then add by 8. So you see, this 8 is undoing the original operation that we had. Well, 10 minus 8 was 2. Well, we want to get back to our original number. So 2 plus what gives me 10? 2 plus 8. So you see, addition and subtraction, they offset each other. So when we're subtracting, we can do adding or addition as the inverse operation because it undoes the previous operation. 10 minus 8. Well, how do we get rid of that minus 8? Or what do we do to offset or undo that minus 8? Oh, well, we add 8 back to it. So you see, our inverse operations will cancel each other out, and it undoes or it will undo what we originally did to our number. So 10 minus 8, well, if we want to get back to that 10, we then needed to add 8. So addition is our inverse of subtraction. And then now for multiplying, I gave 2 examples for this, just so that way you can see it doesn't really matter with our positive or our negative numbers. It's the same inverse, but we just have to take that positive or negative into account. So 10 times 3 is going to give me 30, but 10 times negative 3 is going to give me the negative 30. So remember, I want to now get back to my original number of 10. That's our goal, is how do we get back to our original number? Because we performed an operation to it. Well, if I'm going to go from 30 back to 10, well, 30 divided by 3 is going to give me 10. So once again, I see that I multiplied, and to undo my multiplication, I needed to then go ahead and divide. And you see, we're multiplying and dividing in this case by the same number, by positive 3. So in order for us to undo that original operation of multiplying by 3, we then needed to divide by 3, and it brought us back to our original number of 10. All right, so now let's go ahead and do the next one. Well, 10 times negative 3 is negative 30. Well, how do I get from negative 30 back to positive 10? Well, now I need to divide by a negative 3 because it's negative. And if we want to turn this number positive, well, negative divided by negative is going to be positive. So once again, we can see, all right, well, the first operation that was being done to our number 10 was being multiplied by negative 3. And then in order for us to get back to that positive 10, we divide it again by negative 3. So it's always going to be the same number. For multiplying, we're seeing here that division is what brings us back to our original number, and it's always going to be divided by the same number that we were multiplying by. And that's something that's really important for you to understand as well. So through multiplying, our inverse operation is division. That's what we had to do to get back to our original number. All right, and the same thing, 10 divided by 2 is equal to 5, and 10 divided by negative 2 is equal to negative 5. And then in these cases, same thing. If I want to go back to my original 10, well, in this case, 5 times 2 is going to give me back to my 10. But now, since I'm at negative 5 and I want to get back to a negative 10, I need to go ahead and say, all right, well, I'm not multiplying by positive 2, I'm multiplying by negative 2, because a negative times a negative will give me a positive, and I need to get back to my original number 10. So the same thing as I just was saying, in both of these cases, we divide it by 2, and in order to undo that division, we needed to multiply. But the difference is down here, when we divided it by a negative 2, we needed to multiply by a negative 2 to get to that, back to that positive 10. So you just have to just be aware of when we're multiplying or dividing, we do need to be aware of those negative numbers now. All right. And then as we see, our inverse operation of dividing is going to be multiplying. So these are all of our inverse operations. It's what they undo each other. So addition and subtraction, they will undo each other just like I showed you here. Multiplying and dividing, they undo each other just like I showed you here as well. All right, so it's really, really important that you guys understand these inverse operations, because when we get into more than just one-step equations, which is what we're doing very soon, you have to be able to identify all the operations that are being performed, and then from there figure out, okay, well, how do I undo these operations? It gets a little bit more tricky then because we had to do them in a specific order, and now we're just focusing on just one. But if you understand each operation's inverse operation, then that's always a question you're asking, and it just becomes a little bit easier. All right, so we're going to now go ahead and solve one of each type of these problems where it's a variable, and how we'll actually solve it, use it, and how you'll have to show your work. All right, so now we're going to go into actually solving these problems. So you might get a problem like this that says x plus 25 is equal to negative 32. And remember, this x, these variables, what they mean is they literally just mean something. All right, so I actually wish that the way that, like when one of the first math books was written, they didn't use a variable like x for this. They actually, it was a word that meant something, but as it was being translated through different languages, they didn't have the same sound that they did for this. So then they started to change it so it matched their language. So then when Latin took it over, they changed it to something else, and then eventually it just got changed to the letter X to represent something unknown. But in the original one, it literally just was translated to the word something. So you can use any variable you want. It's just in the future you'll learn that we have to define what those variables are. But these variables, X, Y, Z, T, M, N, V, like you're going to see these all the time, they just represent an unknown value. So it's something, it represents something we don't know, but it's unknown, and now we're trying to solve for it. All right, so in order for us to solve for this, we need to do what's called isolate our variable. And what that means is that we're trying to solve our variable to where it is 1x or 1y or 1z. So we're trying to just get that variable all by itself. And when there's no number written in front of it, like there isn't here in front of this x, it is understood that there is a 1 in front of it. So even though we're not writing 1 in front of it anymore, we know that there is a 1 there. So all these examples where I wrote 1x, 1y, we can just represent it by x, y, and z. So our goal is to get that variable all by itself on one side of the equation and the number on the opposite side. So we're solving for it. So the first thing that you're going to ask yourself is, okay, well, what's being done to my variable here? Well, it's x plus 25 is equal to negative 32. So now I'm saying, okay, adding is being done to my variable. And what is the inverse operation of adding? Well, the inverse operation of addition is going to be subtraction, or subtracting. So now if I'm adding 25, as we showed you in the other ones, when we did 10 plus 8 and we wanted to get back to that original number 10, well, we had to subtract by 8 as well. So when we're doing our inverse operation, we are going to subtract what is being added to it, the exact same, because our goal is to get x by itself, all alone on this side of the equation. And if I subtract by anything other than 25, there'll be something left over. And I'd either have x plus 1 or maybe x minus 1. So the only way to get x all by itself is by adding 0 to it, because any number plus 0 is back to that original number. So we would subtract the exact same amount, and what we do to one side, we have to do to the other. So we need to balance it out, right? And let me show you that. I'll show you this in numbers in just a few seconds. So now these cancel each other out, and it's equal to 0. So x is now equal to negative 32 minus 25. Well, when we're doing negative 32 minus 25, we know that they are the same sign, so we can go ahead and just add those numbers. So this is then going to give me 57. And since they were both negative, we know our answer is actually negative 57. So x is equal to negative 57. All right, so now when we're doing this, the work that you need to show me for sure is your inverse operations. You must show me that every single time. All right, you're going to always hear me say, treat me like I'm an idiot, meaning I don't know anything. But when you show me your work, I can follow along. I'm really, really, really good at following along, but I'm not good at doing it on my own. So every single equation that you solve for me, you must show your work. And this is how we show it. If we're adding 25, well, we're subtracting 25 then, because that's our inverse operation. So show me every inverse operation that you do. You don't, if you can do like negative 32 minus 25 in your head, you don't need to show me this work necessarily. On a lot of questions I give you when it's just one-step equations, though, they are going to be a little bit harder, just so you can't just mentally do it in your head. So that way I know that you're not guessing and checking along the way. But if you're able to do these calculations in your head, you can. This I'm highlighting in blue right now, though, is very important that you must show me for your work. If you don't show me that in your work, you're not going to get credit. All right. So just to kind of show you again, when we were doing that problem 10 plus something, so if we did 10 and we're adding 8 to it, if we wanted to get back to that original 10, well, 10 plus 8 is equal to 18. So if we wanted to get back to that original 10, remember, we would have to then subtract 8 in order for us to get back to that original 10 to say, well, this is 10 is equal to 10. So when we're doing this, if we're the reason why we need to make sure we do it to both sides, well, 10 plus 8 is equal to 18. So now we can say 18 is equal to 18. And when I am doing and solving it and undoing my inverse operation, well, I need to make sure I subtract 8 from both sides, because if I don't, and I won't be able to get that 10 is equal to 10. If I only subtract the 8 from this side of the equation, well, then we would have 10 plus 8 is equal to 18. So we have 18 is equal to 18. And if I only subtract 8 from one side, so let's just say this side, well, now 10 is equal to 18. You see, we're not keeping them equal anymore. So if I have 18 is equal to 18 and I only subtract from one side, now I have 18 is equal to 10. And neither of these are true statements. The only way that we can get a true statement is by doing that subtraction or that inverse operation to both sides. Right, so you must do it to both sides. And we say this, it's keeping it balanced. So if they were originally equal and I only subtract 8 from one side, of course I'm not going to have them equal anymore, because I'm not subtracting 8 from the other side anymore. Right, so you must show that work to both sides. Okay, let's go to the next example. All right, so here we have 5 times some number. That's what x means. So 5 times x is equal to 325. So now if we have 5x, the only way we can isolate our variable, as I said, is by getting it to equal to 1x. So when we're dealing with multiplying or dividing, it's a little bit different in that before we were trying to get that plus 25 to be equal to 0. Here we want it to be equal to 1. So we need to then go ahead and divide. Remember, this is being multiplied. So the multiplying is what we're doing now. And the inverse operation of multiplication is division. So if I'm multiplying by 5, I need to divide by 5. And as I showed you, we need to keep it balanced. If we only do it to one side, it's no longer going to keep it balanced or equal. So we have to do it to both sides. So this is showing my work, because the fraction bar means division. So I can show my work like that, or some people like to do it this way, where they rewrite the problem and then they write divide by 5, and then they write 325 divided by 5. Either way, this is showing your work, because the fraction bar means division, or here you're actually showing me divided by 5. But any one of those are acceptable, but you must show me that. So now we get x is equal to, because 5 divided by 5 is 1, well, we don't need to write 1x. And now we just go ahead and do 325 divided by 5. 5 goes into 32 6 times. So then we can subtract by 30. Now we get 2. We bring down that 5. So 5 goes into 25 5 times. So x is then equal to 65. All right, so this is how you would need to show your work through that inverse operation. If you can do 325 divided by 5 in your head, that's fine. But it's better to show that work as well. But the mandatory is showing me your inverse operations. Without showing me that, you are not going to get full credit. All right, so here we have x minus 219 is equal to negative 534. So once again, we have to identify what operation is being done to our variable. Well, we are subtracting. Well, how do we get rid of subtraction? We do that through addition. That is our inverse operation, so we need to add. If we're subtracting 219, well, I need to get that to be 0, so nothing is being added or subtracted to my variable. So that means I need to add by 219. And what I do to one side, I have to do to the other. They cancel out, and now I get my x isolated all by itself. Now I need to do 534 plus negative 534 plus 219. Since the signs are different, I'm going to go ahead and subtract, and I'll do my larger number minus my smaller number. So now we'll borrow from the 3, so we get 5, we get 1, and we get 3. Since the larger number was negative, I know this is actually negative 315, so x is equal to negative 315. And the good thing is we can always check our work by just plugging this back in for x. So when you are taking a test, if you have time and you plug your answer that you got for x back in, if you don't end up getting a true statement, well then you know you made a mistake somewhere. So at the end of this test, if there's time, you would actually know where you stand before I even grade anything. All right, and then we're going to go through the last example now, but just to reiterate this real quick, in order for you to get full credit, remember you must show your work. So here's the inverse operation that you must show. All right, now we're going to go through the last question. All right, so here we got negative x over 6 is equal to 17. So once again, we identify what operation is being done. Well, this fraction bar means division. So we know that we are then dividing. And what is our inverse of division? Well, that is going to be multiplying. Right? But now what we had to identify, though, is this was actually negative. So when we do our inverse operation, we're being divided by a negative 6 right now. We can think about that as. So I'm going to multiply by a negative 6 because that's what I'm dividing by. So if we have the sign there with a division or multiplying problem, just put that sign with the number. Right? You could do this in two parts if you wanted to and first get rid of the 6, and then you'd be left with negative x. But doing this in two parts allows for you to forget about that negative sign. So just do it all at once. So remember, parentheses mean multiply. So I'm multiplying by negative 6, and what I do to one side, I have to do to the other. And if I multiply by negative 6 and divide by negative 6, well, they're going to cancel each other out to give me a positive 1. So I now have x all alone. I undid that division of negative 6 by multiplying by negative 6. So now I just need to go ahead and multiply these two numbers together. Well, 17 times 6, this will give me 42. 6 times 1 is 6, plus 4 is 102. But a negative times a positive means it is negative 102. All right, so once again, you must show me your inverse operation. And that was just through this multiplying. That was showing me. What some kids like to show, though, is if they had negative x over 6, they would actually show their work. Okay, this isn't erasing, so I'm just going they would actually show their work like this, or if it's negative x over 6, they might show times by negative 6 is equal to 17 times by negative 6. They might want to show those, but this is why you'll say, I'll never write an x for multiplying again because, well, which one is which? So I actually don't advise that you do it this way, but whatever you feel comfortable with. But you must just show me your inverse operations. If you don't show me your inverse operations, I'm assuming that you're guessing and checking, and the highest you can get is AP at that point. All right, that is it for this video. Now there's a couple questions you'll have to answer for me on Edpuzzle, and that'll be it.